Class example 2.33 is going to ask us to factor a polynomial, which is a cubic. Here we're given p of x equal to x cubed minus x squared minus 10x minus 8. Well, in our previous examples, we were told one of the factors to factor out. Here we've been given no divisor, no 0, no x-intercept on a graph. So we have to first decide, what will we divide this by? What will we factor out? Let's first test our potential zeros. We know that the constant term in the expanded form of this polynomial is negative 8. It has as potential factors, it has as factors plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. These represent the potential zeros of this polynomial. Again, we know that a cubic has at most 3 zeros, so it's not possible for it to have 8, but these are all possible. Also, it can happen that 1 0 repeats itself. Let's first evaluate p of x when x is 1. Here we find that p of 1 gives us a value of 18. What we care about is that this is not 0. This confirms that x minus 1 would not be a factor. If we check for p of negative 1, it evaluates to be 0. This means that the factor of x plus 1 is a factor of the given polynomial. At this point, we can factor our cubic by dividing out x plus 1. We need to do more than just the remainder theorem because we actually need the quotient here. Let's use synthetic division. We write the coefficients of x cubed minus x squared minus 10x minus 8 and write the 0 of the divisor, which would be negative 1. After performing our synthetic division, we confirm the remainder of 0, meaning we did in fact divide out a factor, and our remaining quotient will give us the quadratic, x squared minus 2x minus 8. So presently, we have factored p of x as far as x squared minus 2x minus 8 and x plus 1. We won't need the integral zero theorem to move forward from here, because now we can factor x squared minus 2x minus 8 using strategies we have from Math 10 and 20. We determine that x minus 4 and x plus 2 multiply to give this trinomial and break it down. Now we're asked to state the zeros of p of x. Well, given that we've written it in the factored form, this is very straightforward. X minus 4 produces 0 at positive 4, and x plus 2 produces 0 at minus 2, while x plus 1 produces 1 at negative 1. We can use these values to label the x-intercepts on the graph, and can also use these to determine the roots of the corresponding equation. Notice this is an important moment for vocabulary. P of x equals x cubed minus x squared minus 10x minus 8 is a relation between x and an output of p of x. Think of it as x and y. And because it is a type of relation that is a function, we call it a polynomial function. However, in part D, we see x cubed minus x squared minus 10x minus 8 equals 0. We do not have a second variable. We're not showing a relation here. We're simply offering an equation. And an equation doesn't have zeros, it has roots.